Okay, welcome everyone. We are in week 10. So we are gonna work on chapter 6 for the next 3 weeks. So chapter 6, it's all about the SQL in a intermediate to the advanced level. So we are gonna learn about the more complex queries. Today we are gonna cover some of those simple with some extra trick, and then we will prepare more for the Wednesday for the next session and the rest of the next 2 weeks that we are gonna work on chapter 6. We will learn about the aggregate function and built-in functions. So we will see what does it mean by those in the next couple of sessions. And then we will learn about the group by and having by what group by and having. So when we use the aggregate function, we have to use this statement as well. We will learn very good with many examples. So you will definitely uh, be totally fine with understanding all these concepts. And then we will learn about the subqueries. By subqueries, as I mentioned in a couple of sessions ago, so subqueries, which means using one queries inside other queries. It's like a two nested queries in each other. It's a little challenging because it needs more like a advanced level of the querying, but yeah, you will definitely be okay. And then change a statement we will see, and the database view, which we will just create different outputs, different views with some specific syntax. We will learn, we will see. So as I mentioned, today we are doing some like a recap for whatever we have discussed and learn something new for the queries. And the next session and the next weeks, we will definitely dive in more into the SQL syntax. So one more time, SQL, pronounced by SQL or SQL SQL. So originally created by is acronym for Structured English Query Language. So it's like a standard language for creating a database management system, for also asking questions from the database systems. And as we mentioned, we have multiple DBMS, MySQL, SQL, Oracle, a lot of, not a lot of, multiple SQL database systems available. But the one that we are focusing in this class is MySQL, which is very common. And as we know, one of the good points about the SQL, it's not case sensitive, so you can just use whatever character that you want to have. But when you are using the string, when you're using the character, for example, in the quotation, in that case, it matters. So if you use the, for example, I don't know, capital letter or whatever, so it's going to be different in the out. But in the syntax, it doesn't matter. And as we know, the white space is only cosmetics. It doesn't matter in the SQL. So about the uh, all statements that we had so far, select, from, where, those that we already practiced multiple times, exams, assignments, we'll also practice today more. And then group by and having, these two are so important, especially when we are using the aggregate function, we will learn. And the order by, we already worked as it in order to sort ascending or descending based on the different output that we would like to have. And then we learned this is the way that we need to write the statement. And the execution, we already know that. It always starts from the second one, which is the from. And then where group by having select, which means going to be the last one, the last one before the order by. So it's going to choose from whatever table, whatever relation or attribute that you would like to have the output from. So for this chapter 6, we are going to work on the Redcat 2. Chapter 2 was Redcat 1. For chapter 6 is the Redcat 2, which is the like a more uh, advanced version of the Redcat 1. So we will have more tables like a sale item, inventory item, item size. So all the things that purchase item. So these are all the things that wage employee, salary employee, those that is added to this one. So whatever assignments we have, whatever class practice that we are gonna do, it's gonna be on the based on the Redcat 2. Okay. So let's start with some simple example that we already had, and you already know the answer because it's too easy. So for this specific example, what's going to be the output for this 3 lines code? First name and last name is going to be the column that we are going to see. Okay. The rest. What is the condition for this first name and last name? Okay, so we are gonna look through the customer table, the order of execution, and then we will see, okay, which states just those with the New Mexico, and then just give us the first name and last name of the output. Okay, so for the select that we already mentioned, so select exactly, choose whatever column, whatever attributes that we would like to see in the output. And we know that by using asterisk, what does it mean when we are using asterisk? Return all the column, return all the attributes of that table. And if you want to remove the duplication, we use distinct as a keyword in the select statement. Okay, so now let's start coding again today, and the next 2 weeks we are just doing coding. Okay, so please do the coding on your side and just don't watch the screen. So let's first. Exactly. All this query is gonna be on the Red Cat 2. Open your My Educator platform and go to your advanced query editor and database MySQL credential Red Cat 2. So I need to, okay. So the first question that we are gonna work, let me list all data customers from Canada. So please start on your side. All data customers from Canada. So we should start with the select all customers. There's no specific column that we want to see. So asterisk from which table? Customer table, where the country, where the country equal to Canada. And do we need quotation or we don't? We don't. Okay, so that's the simple one that we already know the answer. Okay, which customers first and last name lives in New Mexico? So technically the same. Instead of asterisk, this time select first name, last name, where the state is New Mexico, right? Right. So select first and last name from customer where the state is New Mexico. In which cities in New Mexico do we have customers? In which cities in New Mexico do we have customers? You tell me, select. We just want to know which city we have the customer. So we don't need to know which one or something, just the city matters for us. Yeah, specifically, we want to just see the city name. Okay, the name from customer and which state? New Mexico. Where state is New Mexico? Okay, so if we just run this, so again, Redcat to MySQL, and so we can see in this city we have customers. Okay, cool. Okay, so okay, this one. There's a new point in this one that we haven't discussed about it. I need you to just think about it. Give an alphabetical list of sandals by product name and the total price for 7 pairs. Think about it, how we can have it for 7 pairs. So we want to have the product name, all right? We just want to know the, so select product name is gonna be the answer for us, okay? And also at the same time, we want to know the price for the 7 pairs. So we would like to have a column in this output that shows us this price, but just 7 times of that price. So do you have any idea how we can show it? So this is the from the product table, okay, where we need to have the sandals. Well, the category is sandal, where the category is equal to sandals. So the code that we are writing right now, how many attributes, how many columns it's gonna give us? Just one, which is the product name. But we wanna have the price for the 7 pairs. Any idea how we can address the 7 times of the price for that specific type of sandals? And it's simple. As Albert mentioned, translating the SQL to English to SQL is like exactly translating word by word. 7 times 7 asterisks the price. What's the attribute name? List price. List price. Okay. Now do it on your side and tell me what type of, or how many attributes you are gonna see, how many columns you are gonna see. No. Yes. Yes. Exactly. Look like this one. First name, comma, last name. Now, product name, comma, 7 times list price. So that's one of the type of function that we can do when we are addressing some specific column. So if you multiply by some number, all the numbers under that column is going to multiply by that specific number. So let me now just So this is gonna be the syntax for us. So product name, 7 times list price. So if I ran this one, so we can see the 7 times list price is here. Okay. So if I just add the list price as well, we will have 37 times 210, 35, 7 times 245. So you see, whatever attributes you have with the numbers, you can just multiply, divide it, add, or whatever you want. And also, there is a possibility to add 2 columns to each other. For example, price plus tax. So we can just simply mention, okay, price plus tax. So it's gonna add whatever value under the price with the also other value under the tax column. Okay, so it's simple. There are possible to do this type of math easily. Okay, so right now we can see this one. But what about what would be the output of this one? What do you think? We are gonna have product name for sure. We are gonna have 7 times list price. Sure. What is this one? It's a string. So how it's gonna appear in the output? No. As a new column. How? Okay. What about the under? It's gonna exactly print price for 7 pairs for the whatever sells under that specific column. So right now, if I run it, you see, it's just create another column and each time mention price for 7 pairs. Okay, see, price for 7 pairs, price. Okay, now I don't like this price for 7 pair here. Okay, I want to change it to info, the word info. How can I do that? No. So what should I do here? Uh, okay, no, the point is if I put info instead of price for 7 pairs, all of this is gonna change to the info. You remember the alias? For example, for the customer C, for the product P, remember? Yes, just put info. This info is gonna be the alias. Okay, so run query. Now we just have info here. And we can also have as here. So price for 7 pairs as info. So still the same. Okay. So what's gonna happen now if I put what's gonna happen now? It's gonna rename this one as a total underlying price. Right. And what's gonna happen now? Error. Because the alias should be just one specific set of characters. It shouldn't be any space between. Okay. So now we just learn something new. If you want to add whatever column into the output as a string, you can just put the name, the column, and whatever cell under that column is going to have the same string. And then you can also change it by using the alias. Any question for this one? Because this is so important, especially when you want to represent your output better. Okay, so I don't like to have price for 7 pair here. I would like to have, for example, something more simple and more understandable. Okay, so that's the way that we can use the alias. Any question, guys? No? Good. Okay, so let me. Now let's go to the where clause that we have. Okay, so in the where clause, technically by where we mentioned that you're adding some condition to your output, and based on those conditions, you can have a different output. So by where you need to address something inside the where. For example, where the state is New Mexico, where the, I don't know, the model of the car is greater than over 2000, or where the salary is less than 100K, something like that. Okay, so we can have comparison operator like a equal, greater than, less than, greater than, equal, less than, equal, and also not equal. And then we can also use the between option. We will see the between. We haven't had the between so far. So for example, we had some question that we would like to have the list price, for example, greater than 50 and less than 90. Okay, so we would like to see this one. So if you remember, we mentioned that when you have two numbers, we should repeat the list price twice, right? You remember this one? Okay, and then we can just make it easy with between 50 and 90. We will see the example. That's how the between works. And then another one is the in operator. For example, I would like to see the sales report for New Mexico, California, Washington, D.C., whatever, a couple of states. I can say, okay, where a state equal to New Mexico or equal to, I don't know, California or whatever. By using in, it's making us easier. Where a state in parentheses, California, New Mexico, I don't know, New York. So technically we are just giving a list instead of multiple times mention, okay? We will see the example. Another one is using like operator. For example, when you know there is some pattern in your data and you would say like that pattern. There are some words that, for example, started with the C, E, or I don't know, whatever characters. You would like to find whatever data that have the same pattern. We will use the like. We will see an example. And the null, which the term is giving us those exact cells that has a null value, and or not, the one that we already know. So let's start example. Which product have a list price over 20 bucks? And again, for the next 2 weeks, if you don't want to get bored in class, just type, do the coding on your side, even though it's not okay, it's not right. I think you already noticed that you can just only learn SQL by practice. That's it. So which product have the least price over 20. So it doesn't ask us any specific features of the product. So we can just use the asterisk from product table where, what is the attribute name? List price. List price. Which one is okay? Greater than equal or this one? Which one is okay? First one. Greater than equal 20. Over $20. Oh yeah. Technically don't, yeah, because it says over $20. Yes. But also mention another. But you're right. Because it didn't say $20 and over, just over $20. Show sneakers and boots not costing over $50. So it should be less than $50. But using comparison operator. So select, it's just asking us the sneakers and boots not costing over $50. So it just asking us all the columns. Select asterisk from product table. Let me make a marker. Just this. Did you know, right? So we are selecting all the columns from product table where the category is sneakers or boots and not list price greater than 50. Okay. Or we could have just and list price is less than equal 50. But we are using the and not equal. So these are the items that we can see the price is less than, or using this one. The same output. Okay. List sales where the total of tax and shipping is over $60. So the total of tax and shipping. Yeah. The word category is sneakers or category is boots in the parentheses, and not list price greater than 50 or and list price less than equal 50. What's wrong with the code?
Didn't end this way, but also didn't end right.
Unknown column category in verb column. Category.
Thank you.
You shouldn't have typo. I can have typo. You shouldn't. Okay? No. So list price were the total of tax and shipping. We just mentioned that we can add columns to each other. So tax plus shipping should be over $60. Okay? So technically select asterisk from which table? We are talking about the sale table, from sale table where the tax plus shipping greater than 60. Simple. Like this. So easy. Just by mentioning two columns, by adding plus between them, we are technically adding these two columns. So if I put 1, now we will see the tax and the shipping, which is less than 60, greater than $60. Okay? You see, I just created a new column. The name is tax plus shipping. So the tax plus shipping, you can see the value here. And we can just make this one as total price. Right? So you can just easily create a new column by adding two columns to each other in the select statement as well. No question? Good. List products in category appearing alphabetically, starting with the letter C or later letter, D, E, F, G, whatever. So I just want to know those that started with C and the rest. I don't want to have the A, B in the category. So any suggestion? This is also new. And just don't think complicated. Think very, very simple. Yeah, select all from the product for sure. But what should I put in the condition, in a verb category condition? So yeah, we want to have to select asterisk from product, verb, category. What's the condition for the category? Okay, how I can show it in the syntax? Greater. Yeah, just simple. Greater than, equal, C. Should I have the quotation or I shouldn't have the quotation?
No.
Why no? Why yes? There is no yes, but why not?
It's because coding like they have
At the end of the day, it's a string. So you always have to have the quotation. Okay. So yeah. So now we can see where category is greater than C. So we will have just those categories with the starting letter greater than C. I mean after C, not greater than C. Okay, that's why I mentioned. Think it's simple. It shouldn't be complicated. Least product cost between 20 and $50 inclusive using between. Okay, so just simple. Select the all the columns from the product table where the list price should be greater than 50 and less than 50. So the syntax for it is simple. We can have it in two different ways. Where the list price greater than 20 and less than 50, this is the way that we learn. And we mentioned that you need to put list price twice. But in this one, just simple. Select asterisk from product table where list price between 20 and 50. Simple. Okay. And just so that's the way we can write it. Where the list price between 20 and 50. Any questions so far? All good? List records of sneakers, sandals, heels, and boots using in operators. So technically what we learned is selecting asterisks from the product column where the category is, what is it? Sneakers, or category is heels, or category equal to sandals, or category equal to boots. Okay, that's the way that we learn. And each time we have to mention category. And as we just saw, there is a possibility to have a typo in your syntax. So you are repeating category multiple times, so you would get error. So we mentioned that always we are looking for making the code efficient as much as possible, easy to read as much as possible, easy to write as much as possible. So instead of having multiple times category, we would say, okay, category in parentheses, those whatever names that we would like. So this is the way. So select asterisk from product table where category in these items that we would like to have the output. And we need to remember these are a string, so we should put it in the quotation. And also we have to separate them with comma. Okay? With comma. Let me just run this one. So we can see the categories here. So this is the way that we learned before. This is the way that we can make it more simple. Okay. Find all product with some form of high top in their name. I mentioned that we can use the like function, like operator, when we have some pattern in our data. I would like to know whatever product name that they have these two words, high top. Okay, for sure you don't know how to answer it, so let's directly go to the answer. Okay, so it is starting with the select asterisk from product table where product name like this way. So what does it mean by this percent and also underscore that we should use? When we use the percent, for example, percent I percent of percent. When we call this as a wildcard. Name doesn't matter. When we use percent, it goes to the data, okay, and find the high, these two together, and then check whatever characters that are available before. It could be one character, two character, too many characters. It doesn't matter. And then it goes again, find the top, and also after high, whatever characters that available after high, and whatever characters available before high, and whatever characters available after P. Okay, so that's the way that it can find the pattern. But when I put high underline top, it just look for those words that have HI, TOP at the end, and just looking for one and only one character. It doesn't look for, when we are using the percent, it's looking for many characters. This one just look for those words that have a specifically one character. Okay? When we run it in the example, when we change it, you can understand better. So again, the asterisk is the wildcard that matches any sequence of characters, including an empty sequences. The underline or underscore is the wildcard that matches exactly one character. So let's run this syntax. Let's see the output. Let me also change this one to just show us only product name. Okay, so now we can see. We are looking for those that has a HI top, high top. So we can see here, Rolodex, there's a high, there are multiple characters before. So it counts this one as one of the options. And HI-TOP. Between the HI and TOP, we have the percent sign. So technically by percent, which means we are looking for whatever character. It could be one, two, or many. So we can see the GH is also available. So it counts also this one. And after P, also there is a percent sign. So there is a stickers. So it's going to show us. And the rest. Now, if I remove the percent at the end, what would happen? Huh? It's just going to stop by P, by top, not the high top, just by top. Because still there is a percent between high and top. So it can find whatever. And so if I just stop it, we will not see this output anymore. You all agree? Why is it clear why we are not going to see this one? If not, please let me know. Okay, so we mentioned that when we put the percentile sign after the whatever characters that we have, it's gonna look for the TOP. Okay, I am SQL. I just found TOP. There is a percentile. It means I have to also go one step further and more and more and more and more to whatever characters, whatever alphabets that I can find. I just went one more. There is a space counted. So now I can take the space. I will go one step more. I can see the S. I will take it. I can see N. I will take it. I can see E to the end. And after that, there is nothing. So it's going to just count this one. But when we don't have the percentile, so there is no function for me as a SQL to go more. So when I saw the TOP, I'm just stop because there is no function for me to go further. So right now, if I remove the percentile and run it, so we only have Capri high top. And what would happen if I remove the percentile? You tell me. What would happen if I remove the percentile before H? Starting with H. That's it. It's just gonna start, look for whatever name, product name that start with the HI. So let's run it and see if we have any. We don't have any. But if I put the percentile here, maybe we have some. Yes. HI profile high top sneakers. You see, because we have HI. And there is a multiple characters after HI, and again HI, GH top. Okay, now if I remove this one and just press, put the underline, which means there are how many alphabets? Oh, it's a character. So it's gonna look for the HI and just only I am a SQL. I am SQL. I just have this order to just look for one and only one character. So I will go through the data and see if between HI and T, how many product names are available that there is only one character between these two, which is gonna be probably that one. Let me run it. No. What was the previous one? Because you mentioned something. Which one you mentioned? The high tab sticker. But the point is, I don't have the percentile at the end. So I don't have it. But you're right. If I add this one, it's just gonna show me high, only one character, which is the space, top. Since I have the percentile, so it's gonna look for whatever after P. Okay? Now you just change the previous example that we had. We mentioned that those after letter C, C, D, E. Okay? So how can I mention it? Like C or person. That's it. It's gonna look for whatever characters that have. It's gonna start with those that start with C and whatever after. But the point is for this one, I'm not gonna see the D, E, F, whatever, because just start with the C and okay. Yeah, this is the one that we can have, or I don't know, C or whatever. Yeah. So Last example. List manufacturers, you have the answer, for which the state has not been entered. When the state has not been entered, which means we are going to have the NA as a value. Okay, so simple. Select asterisk from manufacturer table where a state is null. Okay, we can have where a state is not null as well, and we shouldn't put it this null in the quotation. We all know why, because null technically itself is not a string, it's a feature of the database. When we don't put the data, we don't enter the data, so technically there is a null value. So by null, it's just gonna show us the null, those empty cells, those empty values for the data. So we can see that the state is there. So there is no data in our data set that the state is not entered. But if I put not here, it's gonna show me all. That's just the other side. Okay. So let me. We are done with the first part. Any questions so far? No. Oh yeah. Now let's go to chapter 6. And the 6.2. At the end, we are gonna have multiple assignments in this chapter. This is the most assignments that you can find in the chapters and all these assignments that you have. So let's do the first 5 together. Okay. Also, let me share. Okay, good. So let's start writing the first one. Give date and the sum of tax and shipping. So technically, it's telling us we would like to see the date and the summation of the tax and shipping. We just know that we can just easily add tax plus shipping. For each sale from December 20 through December 25th of the 2015, use between, name the calculated column sum. So that alias that we mentioned, we would like to name it as a sum. Due to the anomaly within MySQL for numeric field, sometimes calculated results have 14 decimal places and inexact amount. To ensure your answer is correct, use the round function. We will learn about these functions later, okay? But just now we need to use the round function, and it's exactly mentioned. For example, round parenthesis tax plus shipping comma 2. That 2 is the 2 decimal points. Okay? So now you start writing it. And don't look the screen. I'm just checking your honesty. I saw you. All of them are the simple. The only thing that is new for us is using the round function. Okay. Now you can look at the screen. So select sale date. This is the column that we would like to see in the output. It's a sale date. And all of the attributes are here. Okay. Sale date. And instead of having tax plus shipping, okay, as a sum, it's telling us to use the function. What is the function? We'll learn later. This function is round function, which means it's going to add these two together and round it to only 2 decimal points. And the alias is sum. We can remove this as, we can have this as, okay? So we can have it from sale table where sale date between these two, okay? So this is the summation. If I remove this one, remove these two, you see the sum, how it's gonna be look like. Multi-min, a lot of decimal points. Yes.
Whenever you do like the sublet,
Mm-hmm.
does it always do it that way? Good the month.
Yeah. Remember that table that I showed you in the last couple of sessions for the date? We have different dates formats. You need to choose one of them. This one is one of them. So the year, month, day. Yeah, yeah.
But is it always gonna be the year month?
Yeah, this one is always works. Yeah, those always works because the SQL can translate it to whatever version it has. Always go with this one. Date, the year, month, date, date. List the data in the salary employee table about salary employee earning between 40K and 50K. Use between. Simple. Look at the screen. Select asterisk from which table? Salary employee, where salary is between 40K and 50K. That's okay. And for the previous example, you saw it. For the date, we have to put the quotation as well. Just gonna try to show you these first 5. Give a customer IDs and the cities for customer who are located in Chicago, blah, blah. Use in operators. So technically select customer ID city from customer table where city in Baltimore, Chicago, St. Louis, and New York. Have you been into New York? For the first time that I went there, I had this expectation that it should look like the New York city, but it was totally different. No, just a different expectation I had. Because the name is very similar to New York, New York, New York. Okay. And the fourth assignment. What is the customer ID for Sam Gill? Easy. We want to know the customer ID from the customer table, where the first name is Sam in the quotation, and the last name is Gill in the Gill or Jill, I don't know, in the quotation. Is it Gill or Jill? Gill. So the customer ID is 7670. I just like the last one. Okay. Give the sale data. Do this on your site. For sales, where sales tax was charged and the total of tax and shipping is less than $15. Use the not operators to show all sales data. So we would like to know those that the sales tax should be greater than 0. It should be charged. And the total of the tax and shipping is less than 15. So there are two conditions. One condition, tax plus shipping less than $15, and the sales tax should be charged. So technically we can say sales tax not equal to 0 because it says use the not operation. Okay, so this is the way. Select asterisk from sale table where two condition. One condition, the easy one, tax plus shipping less than $15, and tax were not tax equal to 0. Or we could have, I would do that way, where tax greater than 0. Okay, but this one mentioned that use a not operator. Probably you would do the same. Which one you would do? Not or just a regular greater than 0? Regular. Simple. Good. How was today? Good. Refreshing. Good. So again, the next following weeks, we are just gonna coding in class. It's gonna be more fun. So let me stop recording. Okay, welcome everyone. We are in week 10, session 2 of the week 10. We started chapter 6 as we discussed on some kinds of same thing that we discussed on chapter 2 last session, but we learned something new. For example, how we can easily, for example, add some column to each other, add some attribute to each other, and put an output, or for example, do some mathematical calculation. For example, the example that we had 7 times the list price for the pair of shoes. So we saw all those things, and today we are gonna go and look about the join function, the function that we already worked on the chapter 2. But for the join function, we are gonna go a little deep and see different type of join function. Okay, so for the next 2 weeks, every session we start with exactly this PowerPoint, this slide, to just review these statements and to just at the end of the day memorize all the order. So again, we know it when we are gonna write the SQL code, we start always with the select function, then from, where, group by, having, and order by. And we know that the version of the execution is first to start with the from, then where, then group by, having, select, and at the end order by. So you're practicing each session because you don't need to memorize it, you have to practice in order to learn, but we just want to every session remind you the order. So because the order matters a lot, especially when we go to the following sessions, we work on it, the group by and having by, then we are using the augmentation function, so you will see in the previous version. But let's first go to the join. Any of you just tell me what was the join function? Yeah, what does it do? What does it do? Two more tables together. And what was the what should be the condition between these 2 tables in order to be joined together? they share some key. For example, primary key of one is going to be considered as a primary foreign key of the other. And for example, we have the sale table, we have the customer table. Here we have sale ID as a primary key of one and customer key. And here we have customer key, customer ID as a primary key. So technically the primary key of this one is the foreign key of the other. And we mentioned that we had, for example, select from, for example, sale table. We join to the product table. For example, sale table, the customer ID equal to product, the customer table, customer ID. So we had this before. Okay, so that's how the join function works. So technically, in this example, we want to see what is going to be the output of this two table, what we are going to see in the output. We are checking the sale information and the customer information. We all agree that at the end, we are going to see those customers that purchase something. We are just checking this in the output of this specific example, okay? So technically, we are extracting some information from these two tables through this path that we have, okay? But now, today, we are going to learn, we have multiple versions of the join. We have inner join, left outer, right outer, full outer, and Cartesian, okay? So the version that we already know and we already learned, we call it as an inner join. So technically, we know what is inner join is, okay? But when we see what is the outer, especially the left and the right, and the full, you will understand better what are the difference between these, okay? Hello, guys. So you didn't miss so much. We were talking about the join function. That's what we already learned about the join function. That when we are using the join function, we are joining from one table to other table through the primary key, foreign key. We know all this from the chapter 2. And now we are just going to start about the different type of the join function, which the first one is the inner, the one that we already know, and then left outer, right outer, full outer, and the Cartesian that we will learn. So the first one, the inner join, the one that we already know, we already worked on it. Let's see these tables and these two circles, and we will understand better about the inner join, the one that we already know. So A is the table A, B is tables B, okay? Whatever in common between these two, we consider as a C. The output of the inner join is just this C part, okay? So again, this is the sale table. This is the customer table, okay? I want to see which customer purchased which items. So technically, I want to see this area, which we call it C. So this is the part that we mentioned, select from sale table, join customer table on, for example, sale.customer ID equal to customer.customer ID. Okay, so this is the version that we used to have in chapter 2. The way that we can join from these two, join these two tables together and extract the data. So this is what we call as an inner join. Okay, the one that we already know. Let's see this example. The table A is the instructor table. Table B is the section table. Okay, so what should be the output? Someone just interpret the output for me. We want to find the common area between these two. Okay, let's start together from the prof ID 1. Do we have any match for the prof ID 1 in the table B? Yes. So it's going to be section ID 2 CS 614. So the first row is prof ID 1, which name is Anderson, section ID 2 CS 614, right? Okay. Now let's go to the second one. Prof ID 2, we have it. Prof ID 2 ball, and the room is CS 615, and the section ID is 1. Okay. Prof ID 3. Do we have any match for Prof ID 3 over there? No, we are not gonna consider it. 4, we have. So technically the output is these three rows. So technically this is the C part. This is the common data between these two tables. This is what we already learned. Okay, we call it as the inner join, or the default version of the join function. Okay, any questions so far? This is all that we have already learned. Now, let's learn about the outer join, and we start with the left outer join. Okay, first regarding the syntax. So technically select asterisk, same, from which table, table A, same. Instead of using join, we mention left join or left outer join, okay? To the table B on, for example, prof ID, which is the common key between these two. But first, pay attention to this point. When we are saying table A, okay, to left join table B, okay, which means we are joining from the left table to the right table. But which one is the left table? The one that we first write. So technically here, table A is the left table, and table B is the right table. So whatever comes first, considered as a left one, okay? So from left to right. The first one is the left table, second one is the right table, okay? So this is the left. But what does it mean by using left join? It means we have sale table, table A, customer table, table B. So let's put A, B, and the common are C. When we are saying we are using the left table, just stay with me, which means we want to have this common key plus these unmatched data. Okay, so what does it mean? It means whatever data that is matched, like the inner join, we would like to have those. And also, I would like to have those that there is no matched data for them in the right table, in the other table. Example, we have employee table, okay? We have employee table. Employee table, I just made the example. And the employee ID is the key. And also we have the sales table. Okay, let's, instead of employee, let's say again customer. And this one is the customer ID. Customer ID, this is the sale ID, and the foreign key is the customer. Okay, so technically these two tables can be connected through the customer ID. Okay, when I use the inner join, I will have the report for the customers that purchased. Okay, the customers that purchased item from us. Okay, but when I have the left join, I will have the customers that already purchased plus those customers that there is no sales data for them. This is the left table. This is the right table. We are going from the left table to the right table. This is the one that we are going to write it first and then sale table. So right now in the output, I am going to have the customer information that purchased some item from us, plus some customer information that they haven't purchased anything from us yet. So maybe the example is not a good one, because if they haven't purchased anything, why they should be a customer? You're right. So maybe we just better to go back to the employee table. So technically we have some employee that they purchased some item, and there are some employee that they haven't purchased anything. I just want to know those employees that purchased iPad for themselves, and also those employees that they haven't purchased iPad for themselves in their company, in their organization. So that's why in this version, in the left outer version, I'm gonna see those employees that purchased plus those that haven't purchased. Imagine my name, Hossein Mohit. What is your initial? MS. Okay. So this is the Hossein Mohit. This is the MS. Hossein Mohit purchased one iPad. Okay. MS has not purchased. If I use the inner join, the normal join that we had in the output, I'm going to have Hossein Mohit purchased one iPad. This is the version that we already have. But when you're using the left one, we are going to have the Hossein Mohit that used iPad, which is the part C, plus the MS that hasn't purchased anything yet. Okay. Now let's see this example. In this table, we want to join these two tables together, which means first we are going to have this C area. What was the C area? There is a common data between these two. So prof ID1, prof ID1, CS614, section ID2, have it. Prof ID2, prof ID2, CS615, section ID1, we have it. Prof ID3, is there any value for prof ID3 over there? No, but we want to have it. So in this case, instead of 0 here, we put null for it. So we have prof ID3, we have the name McDonald. Do we have a section ID for it? Do we have a room for it? Null, no. Then prof ID4, we have the data for it. So technically, we are joining from the left table to the right table. Was it clear? What does it mean by join or by left join? Yes. So when we also have more examples, you're gonna learn better. So the next one is gonna be the right outer join. So by right, which means this time, again, table A is gonna be the left one, table B is gonna be right one. When we are saying right one, which means we are going from table B, the second table, to the previous table, to table A. So technically, we can just say that we are gonna have the B and the C part in the outer. But the point is, using the right outer is not that much common. Do you all agree if I mentioned from table A to B, the left, this one is equal to table B to A with the right. So instead of going from this one to this one, I'm gonna go from that side. So that's why there is no point for using the right version. We can always just switch the table and just use the right version, okay? But let's see this example. We are going from the right table to the left table this time, because this is the right job, okay? So table B, prof ID2. Do we have a value for prof ID2 over there? Yes. So we have prof ID2, name, ball, whatever. Prof ID1, do we have? Yes, Anderson. Then the rest of the information. Prof ID5, do we have any value over there? No. But the point is, we just mentioned the section ID because there is no primary key and foreign key match for the file. So we would just mention the CSC, CS66, CS621, and section ID is 3. Okay, and the rest of the information is null for prof ID 5. And for the 4, we have the same. Okay, so technically, again, as we also seen in this slide, the right outer rarely used, so it's not that much common. So we can just reverse it and use the right or right instead of left. Using left instead of right. I'm just changing the tables. The last version is the full outer version, which we can just easily say that, which means we are gonna have all the records A, B, C together. Okay, so technically just the combination of the left or right together. Here we will have all the information for prof ID 1, 2, 3, 4. 1, 2, 3, 4. For the 3, there is no data in this side. Null for the section 3 CS621 for the prof ID 5. There is no here, so null for that one here as well. So technically, the combination of both could be considered as a full outer join, which means the right and left together. So technically, you are going to have all the output available. Again, depends on the different context. You need to use some of them. But for our case, for example, for the assignments, for the exam, you will have some hint to use which one. Okay, we will see in the assignments and also in the examples that we have. Okay, so one more time, if we just take this couple of seconds I'm mentioning, so you understand the join function, different table join function. One more time. I'm repeating this example because it's gonna help later for us. We have again employee table. We have sale. I know purchased. That's a purchased item by employee. Okay, here Jose Mohit purchased, for example, one iPad by Jose Mohit, and MS, for example, purchased nothing. what? MM also purchased one iPad. So when I ask you, give me the output of those employees that have already purchased iPad. Okay, so in this case, you need to use normal join, which we call it inner join. So from the employee table, joining to the purchase table through the common key, which is the, for example, employee ID key here. And in the output, I'm going to have HM, I'm going to have MM. They both purchased iPad. Okay, but I would ask also, give me the list of the customers that give me the list of the employee that purchased, for example, iPad, plus those that haven't purchased iPad. Okay, in this case, we need to use the left. We go from the left table to the right table. In the output, we are going to have the HM, purchased iPad, MM, purchased iPad, but MS, that hasn't purchased anything yet. So we are going to have null for it. And if I ask, give me the list of the employee that haven't purchased anything yet, what should I add to the statements that I have? No, this is exactly the same code. I just want to know which one that they haven't purchased anything. No, so we can use exactly the same code from select asterisk from employee table joining to the purchase table. through the common keys where the, for example, the item is null. In that case, I'm just filtering the output to only having the null value. Good. The last one, Cartesian. I still have no idea why we should have the Cartesian, but that's the type of join. So technically, for each observation, for each row in one table, you can have exactly, for example, here for the one Anderson, you can have one Anderson for one CS 615, two CS 614, three CS for 621. So technically, three row here, three row here, three times three, which is nine. Nine is the number of the observations. So we can see here for the CS 615, we have all the observation of the other one. CS 614, all the observation of that table, and also CS 621, all the observation of the other. So technically, just gonna combination of the all pairs based on the question. You have question? Oh. So that's also considered as a Cartesian. So all possible combination, no primary or foreign key pairs. Okay. So that's the join syntax that we already know. Just some points. First of all, using alias is always good. Make sure to use it. And the point is, like in 90, 80, you can find the right. Let me just. In 6.4 multiple table queries. Okay, I think we have it. Oh yeah, before this 1992, the early stage of the SQL coding, instead of using join, they used where. So how? So let's see this example in the book. So we are having a listing sale of the black sneakers. Okay, so selecting some column doesn't matter. Let's assume it's asterisk. From the sale table, joining sale item table by these two columns, these two attributes, sale ID, joining product table by these two, where category is sneaker and the color is black. Okay, so this is a normal version that we. But in the old days, before having the join syntax into the SQL, they used the where instead of join, and then they came with the join and make it easier. But again, still the where function also works. This is, I don't recommend to use it. Always make sure to use the join. But the main purpose of the book on this section is to just telling you that's how the process went from the where to the join function. So here again, the same example. So select whatever attributes from the sale table, sale item table, product table. This is how they mention where sale ID of the sale table equal to the sale ID in the sale item table, and product ID in the sale item table equal to product ID from the product table, and category sneakers, and the color is black. Okay, so technically exactly the same output. Okay, but now before going to the example, let's learn one more, which is the union function. So what does it mean by union function? We are not going to joining tables together, okay? By union, we are going to just adding some rows, some observation, some data from one table with other tables, with some different rows, some different records of data, they are going to combine them together. So we have three types: the union, except, and intersect. What does union do for us? It's going to combine all records, except, we will see in the example, except combine all records from the first one, but exclude the duplicated from the second. So if there is any uh, same rows in that table, it's going to exclude it. And intersect, return only record that are in both sets, just the common one. Okay, so this is how we will write it. We will see in the example. Select column from table 1, for example, whatever column that we have. Union, select column from the table 2. We will see in the example. So that's how the union, except, and intersect work. Again, it's not joining the tables. We are just taking some rows of some table with some attributes plus some rows from other tables with some other attributes. We are just merging them together to have the out. So let's, like the previous session, start working with these examples. And I need you to also do the coding on your site. So the first one, select all fields from the join product and manufacturer table for the manufacturer name Fila. So we can just easily say that we are dealing with product table and manufacturer table. Select all fields, which means select asterisk. From the join product, we are going from the product table, joining to the manufacturer table, where manufacturer name is Fila. So technically, we are selecting asterisks from the product, let's call it P, joining manufacturer, call it M, on P dot, what is the attribute's name? Manufacturer ID, MID equal to just manufacturer MID, where the, what is it, the category? No, manufacturer name, Fila. Manufacturer name, quotation, Fila. So just first of all, make sure to work on the red cat too. So this is the syntax from product, P table, joining manufacturer table, on which attributes, manufacturer ID, where manufacturer is Fila. The same that we have already learned. And the output is gonna be those products that manufactured by Fila. Am I right? That's how the inner join function works. But if I had the left join, I would have those manufacturer that created by Fila plus whatever manufacturer that created product that manufactured by other brands. Do you all agree? If I had the left version, what would happen? if I had a left for this version, I have the product that only manufactured by Fila. Am I right? Right? If I had the left one, I would have the paired match, which is the product that manufactured by Fila, and the products that manufacture but whatever other brands is as well. So that's the left version works. So let's have second example. List, sale ID, sale date, product ID, quantity, sale price, and extended price, which is gonna be the quantity times sale price, okay? For all sales. So first of all, it's exactly telling us to have which attributes. Sale ID, sale date, product ID, quantity, sale price, and the quantity times sale price as extended price as an alias. Okay? From the we have two tables in the red cartoon. We have one sale table, we have one sale ID table. So technically, we are going from the sale table to the sale item table. So we have selecting those attributes from sale table, join sale item table on the common attribute between these two is the sale ID. So technically sale dot sale ID equal to sale item dot sale ID. Okay. Answer is this. We are going to have select sale ID, sale date, product ID, quantity, sale price, quantity times sale price as extended price from sale table, joining sale item table on the sale ID, which is a common key between these two. Okay. Do I need to have this as here, or can I just remove it? Yeah, I can remove it. And in case if you don't remember the table, do we have a table here? Oh yeah. Open. We have operation. So here we have the sale table and the sale item table. The common key between these two is the sale ID and some information for the sale available here, like for example, sale price. Okay. And you might say, how would I know I need to use the sale item? In the questions, it's mentioned, use the sale price. Sale price only available at the sale item table. Okay. Just try to write it even from this screen. Yes.
So you see in your first selected,
Mm-hmm.
cell ID.
Mm-hmm. The point is, since we have sale ID in these two tables, we are joining from sale table to the sale ID, so we need to address it from which table? Here we are addressing from the S, which is the sale table. Yeah, because the point is sale ID are available in two tables. I think we should have error. Yes, you see, sale ID in field list is ambiguous. It doesn't mean we haven't make it clear to which table we are using the sale ID. But the rest, they are unique. Sale price only in sale item table, quantity, product ID. The product ID is only in these two tables. It's just this one, quantity. The only thing that's common is a sale item.
Say for example, if you had like the item to inventory item,
Mm-hmm.
you had to get
Sale item to which table? Inventory item.
yeah,
So how many key we have? Product ID, it's item side. We can choose based on the question. If we, for example, need to work with the item size, we can use the item size, or we can use the product ID. It's a common key. They have this. They are going to have the same output for us. So technically, for whatever data sets match between the item size, we are going to have the result from this table as well. Okay. And that's exactly what I always mention, critical thinking. Think this way. What if I change it in this way? What if I use that way? What if I remove this one, add that one? That's the only way that, believe me, that's the only way you can learn coding. The only way. Just by sitting here watching this, you will never learn. By if you just challenge your brain, think, not very challenging tasks, some simple like this one exactly. What if I go to this from this one and choose different one? What if I, for example, selecting the attribute from this table instead of this table? That's the only way that you can just challenge your brain and learn it. So let's go to the third example. List employee with the name of their managers. Just before starting, employee, we have employee ID. Let's see here, please. Employee, we have employee ID. We have manager ID as well. And we know that the employee table, they have a recursive relationship. Okay. What was the recursive relationship? Relationship with itself. So I'm employee here reporting to my manager. My manager is employee here reporting to his manager and to the top people in the organization. So we need to work with this table. But the point is, we need to use this table twice. Once for the employee, once for the manager. So technically, we have to address this table twice, one as the employee, one as a, for example, supervisor. So one table, but we are using it twice. So we are going from employee table to the, for example, supervisors table, but they are exactly the same table. So let me just have the question one more time. This is not a challenging thing, but just think a little about it. And you tell me what should I do. We want to have the name of the employee, employee name, and just writing very general, and the manager name, employee name, manager name in the out. So technically, since this is the first name and last name, we are going to have 4 attributes in the output. One first name, one last name of the employee, one first name, one last name of the manager. But the point is, we want to know also who report to who. So which table has a relationship with which table? I mentioned exactly. The employee table has a connection with itself. Once the employee table considered as a E as an employee, once the employee table considered as the S as a supervisor table. So now joining the employee table to the supervisor table through which key? Employee ID, manager ID. from employee ID as a E, join employee table as a S, as a supervisor, on employee ID, employee ID from the employee table, manager ID from the supervisor table. Something like this. The selected statement is a little too much. Just first name as an employee first name from the employee table. Last name as an employee last name from the employee table. S dot first name, which is a supervisor first name, as a manager first name. S supervisor as a last name, as a manager last name. From which table? From the employee table, joining again employee table, but this time we called employee table supervisor table. On which attributes? Manager ID and employee ID from the supervisor ID and the employee table. Let me just run it here. So here we can see that, for example, this guy, Louis McDoug, so that person report to himself. Audrey report to Louis. Kylie report to Louis, unless we have Jerry Sacrenton report to Audrey. Audrey report to Louis. So we can see the hierarchy as well. Yes. So we have it exactly like that. E dot employee ID, S dot employee ID. Oh, no. Because in that case, we are not addressing the manager. We want to know who is the manager as well. That's why we should have the manager as well. But let's do it and see what's gonna happen in the output. So Louis, you see each person report to itself. You see? That's the critical thinking. Thinking what would happen if I change it this way. Now you can understand the syntax better and better. Mm. List the customer name with product category and product description of the products. Sorry, list the customer name with the product category and product distribution description of the products each customer purchased. So we are dealing with some tables. We are dealing with the customer table, we are dealing with the product table, and also we are dealing with the sale item table as well. Let me just see the table. So we are dealing with the product table, sale item table, and the customer table. Let me too much. So read it for me. category, product name. Okay. So we are customer going to the sale through the customer ID. Then we should go to the sale item through the sale ID. And then to the product table to the, so you see that's the path. Okay. So now product IDs come between these two. So technically we are gonna see the customer information, the category type, and also the product name. So if I have the description, do we have it? Where, where is the description? Description. Do we have it in just one place or this script? I admitted I had typo. That's normal. Okay. DIS. Oh, 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 okay. Oh, that one. Oh, this is it. Okay. Oh, it was okay from the first. Okay. Yeah. Yeah. I have to ask. Oh my god. Oh, no. There is a. Oh, this. Okay. There's this. So we can also have this information. It wasn't a big deal. So this one. List all customers who did not complete a sale, and I expect you all do this. List all customers who did not complete sale. We are dealing only with two tables, the customer and the sale table. The customer, sale. I want to see those customer they haven't purchased. Hmm? The cell should be empty or null, but how we should address it. If I use the normal join, I will have just the customer that have purchased, right? Right? So if I use the normal join, I will have just this area. But I want to have those customers that they haven't completed any purchase yet. So what type of join function we should use? Left. When I use left, what's gonna be in the output? All customers, exactly, those that have purchased plus those have not purchased. But I need one more condition. What is the condition? Those that the purchased item for them is null. Okay, so where the sale ID is null. So this is it. Select first name, last name, sale ID, sale date. From customer C table, left join to the sale table. So we are technically having these two areas. By that last condition where sale ID is null, we are just gonna have this area, not this one. Right? Makes sense? If not doesn't make sense, let me know. Yes. Left plus the comment plus this area. That's how left works. So one more time. So table A, table E. Left joining A to B. Left join, which means we go with the left one to the right one. So in this case, we will have those common match, which the C area, and also the A area. C area in this example is those customers that purchased item. Okay. This A area is the customers that have not purchased anything yet. Okay. So with that extra condition where sale ID is null, we are just gonna have the A side, which is this part. B side is gonna be just the sale report, whatever sale report we have. Okay. B side is the customer side. Is the in this case sell, customer sell, customer sell. This is the customer side. This is the sale side. Okay. This is all the sale information. This is all the customer information. The common part is all the customers that purchased something. Left side is only the customers that haven't purchased anything yet. So you see, these are the customers that the sale ID is null. If I take this one out, we are gonna have those customers that purchased plus those customers that have not purchased. You see, that's the difference. Yes. Which one? Sorry, would you the previous example? Let me. You mean this one? This one, you mean? Okay. Yeah, just let me. So you have the same syntax, am I right? So that's the name of the customer. That's nothing big deal. Just the name of the customer is Yeshu.island. Yeah. This one, Ping Cheng. This one, Ali Kamrani here. He's Persian. Okay. Cool. So let's go to the last one. Use union query to list all customers from the state of Minnesota with a column literal from Minnesota and all other customers with a literal not from Minnesota. So let's just directly go to the answer for this one to understand the union better. When we mentioned that by using union, you're combining some rows from one table with some rows from the other table. Okay, so select first name, last name, state from Minnesota as customer state. We had this one on Monday. When you, for the example, you had 7 type of shoes, something like that we have. Okay, from the customer table, where state is Minnesota. Union. Second table, select first and last name, state not from Minnesota as customer state. From customer table, where state is not Minnesota. So in this case, what should be the output? We are gonna have the first name, last name, state Minnesota, mentioned from Minnesota. But if the state is not Minnesota, Florida, mentioned not from Minnesota. Okay, so that's only the union function aspect. So we are a little close to finish. So let's and all of these things, as you know, is already recorded, so it's gonna be on the YouTube. And
The union like next two different areas.
it's just combine them. That's it. Combine the output together. I have some output plus some other outputs. Just combine them together. That's it. Let's say it's like a type of different view of it. So we will learn about the view later, but something like that. Yeah.
What if same customer table?
Mm-hmm. Mm-hmm. No,
Maybe not this example, but say like first name
mm-hmm.
maybe B,
And
and so first name you had to specify from which.
the point is select from technically is one statement and it's done. Union from the another syntax. So technically, if you're using both in the same select from whatever, in that case, you're right, you have to address it. But here we are just dealing with the customer table. Here we can deal with other table, whatever, and they might have the same attribute. But the point is, this is related to the another query. This is another query, two query combined together. Let me go to the assignments. So 6.4, we have let me fix this one. Okay. So assignment 6.2. Again, the same dataset, same table. So let's have the first one. Who are the customers from Illinois? Let me just who are the customers from Illinois who have bought boots costing over $100? Show first and last name only. So we need to have the select first name and last name. customer from Illinois who have bought boots costing over something. So here we have the uh, customer table, we have the sale item, sale, and the product. So we have to join to these tables together. Yes. These are the tables that you need to connect. I'm just mentioning them generally. I haven't said exactly which one to which one. But let's see this one. So we have to select first name, last name. From the customer table, we are joining to the sale table. Okay, through the which one? Customer ID. Then joining to the sale item table, sale to sale item through the sale ID. Then sale item to the product table through the so technically first customer sale. You see, there is a path. The only path between the customer and sale is the customer ID. Am I right? Then customer ID to the sale table, sale item table. Then the last one, which is the sale ID table, sale item table to the product table. Inventory item isn't included. Let me see. Who are the customers from Illinois who have bought boots costing over $100? The list price is not available here. The list price is available only in product table. No, no, it's extra. There's nothing. There is no point for us for joining them. We have product ID. We have product ID, so we can just easily merge these two tables together, right? If you have been asked to, for example, put the I don't know quantity on hand or item size or something, you have to address the inventory item. Again, just pay attention what they ask you. Okay. Which name? What are the names of the product from manufacturers in Washington State? So product, manufacturer. What are the common key? Manufacturer ID. Where the state is? Washington. So product name from product table, manage manufacturer M, product table P. So they're joining through the manufacturer ID table, which where state is Washington, right? The last one. List hourly wage employees first and last name, their hire date, and then the full name of their manager. Rename manager name as a manager first and manager last. So hourly wage employee, which is this one, and the employee table is this one. So you need to connect those. And again, all of this is going to be uploaded for you later. So you can just go back and watch all of this. So we want to go from the employee table to the wage employee table. Employee as a E, wage employee as a S, and joining through these tables together. Read it for me. Summary read the syntax for me, especially the last two lines. Mm-hmm. 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 Manager table. Mm-hmm. We call it S. Yeah. from the employee table. Technically, you are connecting these two tables together. We are connecting employee table and wage employee table together through the employee ID. And also, we want to see which employee report to which employee. So that's why we have to address manager ID from the employer and employee from the what is it? The employee table, manager table. Sorry. So that's how we can also address it. So we can see who report to who is the boss, all the things. So let me stop sharing.